Hello, I'm Robert Emmett Hernan. I'm head of Blue Stack Productions, the publisher of Irish Environment, an online magazine covering environmental matters on the island of Ireland. I'm very happy today to be here in Dublin at the offices of the Geological Survey of Ireland with Monica Lee. Monica, how are you?
I'm very good, thank you, Robert.
Now, Monica, what's your position within the Geological Survey of Ireland, which we'll just shorten with GSI?
Great. Yes, I'm a principal geologist, one of three here in the GSI, and I'm over the groundwater section and have oversight of the land mapping section as well.
Now, one of the things that I wanted to talk to you today about is that I don't think a lot of people in the environmental community have as clear a sense of what contributions the GSI makes to environmental protection, and I want to explore that with you today.
Okay.
So I thought we'd start with you maybe giving the audience a sense in a general way what GSI is and what it does.
Okay. Well, the Geological Survey of Ireland is basically the National Earth Science Agency. We've been established since 1845, so it's quite long running, and we're just in the Department of Communications, Climate Action and Environment, so that's a new division since the last government. I suppose our core function would be as a data centre for geological information, and we've always produced geological maps and applied products. We also provide an advisory service, and in terms of environment then we have some specific sections that would be I suppose more focused on the environmental sides. If I give you a general overview of the organisation itself, we're quite small. We have 40 permanent staff and between 40 and 60 contract staff, depending on the projects that we have at the time. We are split, I suppose, into a mapping area, so that would be land mapping, which is the traditional geological mapping, so bedrock and quaternary, which is underpinning all of our applied products. We also have the seabed mapping programme, and you have the large Infomar project, which is a joint venture with the Marine Institute, and then also more recently, I suppose, the TELUS airborne geophysical and geochemical ground survey programme as well. So they would be the mapping programmes, and then we have the applied programmes. On the environmental side would be the groundwater programme, which I can talk about in a while. Then we also have the geohazards area, so landslides would be one of the bigger programmes there, and then also the geological heritage programme, which is again really based on environment and protection.
Now, you said it's an advisory function. Now, who typically would GSI be advising with the mapping and the data that it collects? Is it local governments or the?
Yes, we work with different agencies. So, from my point of view, the Environmental Protection Agency, EPA, would be one of our largest stakeholders. We also work with local authorities, National Parks and Wildlife, different divisions like that, with the OPW.
Office of Public Works? Office
of Public Works, yes, that's right. And yeah, there will be a large number of stakeholders of that nature. We advise on policy. We work within our division. There's obviously the EMD, the Mining and Exploration Division, and also PAD, which would be a Petroleum Affairs Division. So, we try to advise and work together with them as well. They're on the regulatory side, and we're more on the information side. So we're actually an independent scientific organisation that feed into these different stakeholders, and then also our products are driven by what they require.
You're head of the groundwater section of GSI, so I thought we could go through that in a general way, and then we're going to come to a couple specific projects that we've talked about. One of the things that you're responsible with groundwater protection schemes, and if you could tell us what that entails generally.
Yes, well that's, I suppose, groundwater is quite important in Ireland. It supplies maybe in around 30% of public water supplies, and we've actually been working with Irish Water to refine those figures, because there has been some discrepancy over the years of what's been called groundwater and what's surface water. Then also we have, outside of the public supplies, there would be the group water scheme environment, and groundwater supplies 70% or so of those, and then there would be private boreholes or springs that are used, so for individual houses. So it's quite important, and we have obviously, similar to other countries, different issues with that. I mean, some of the highlight ones would be perhaps cryptosporidium leading to boil notices, E. coli, VTEC has been a recent one that's been highlighted in the media, and then just general background issues that maybe are around different land uses, agriculture, septic tanks, that type of thing. So we've had to map the geological resources, the aquifers. We've had to map the protection that's afforded by the overlying soils and subsoils, so then we have a vulnerability layer essentially. And then we also have, with the local authorities, mapped around their specific drinking water supplies. But we haven't done that in a comprehensive way. It's been, highlighted where we need to do that, the more important ones.
Okay.
So we don't have all of those mapped yet, the catchment areas around those. Those maps then are then combined in a specific product, which initially was for the local authorities. And within that product, we also highlight a tool whereby planners who wouldn't be hydrogeologists and maybe wouldn't be able to interpret the maps as well, could look at our product, click on an area for a certain activity, and the product will tell them, based on those divisions in the groundwater resource and protection, whether that activity should go ahead or not.
Like a landfill.
Exactly. So we have specific activities that we have those responses, we call them, for, and that there would be landfills, land spreading, septic tanks, domestic wastewater treatment systems. There's earthline slurry stores at wintering pads, and also for wetland treatment systems.
Now, you also work with the important water framework directive from the EU. And what's your involvement with that issue?
Well, the EPA are the competent authority that reports the EU on all of the water framework directive issues. We've been, an instrumental part within that process. I suppose initially in the characterisation, so with the groundwater bodies as part of the water bodies that are delineated, so the management units, our aquifer map would have fed into that. And in fact, our aquifer mapping process was accelerated by the need of the Water Framework Directive. So we were at the characterisation phase, as opposed to surface water, where we have a lot of data that you can actually assess what the status is. With groundwater, there are fewer data. So we need to run risk assessments to see what the likely risks are. So the EPA would take our characterisation layers, compile those with the potential hazard layers, or the land use layers, and then come up with a risk category. And then they have carried on that process by doing specific monitoring for type areas to see how well that risk assessment has been carried out.
Now, you also work with the karst formations. I wonder if you could tell the audience what karst is and what work you do in a general way.
Yes. So, karst forms in limestone rocks, and in Ireland, 2/3 of the country is in some way limestone, whether it be a very pure limestone or perhaps a muddier limestone. It's formed under the sea, so you can imagine it may have been the shells and the calcium that forms the pure karst, or it may have been maybe layers of mud that in deltaic formations that would have mixed with that. So it can be very variable. And what karst is that when groundwater moves, it will, especially in Ireland where it's fairly old rocks, it moves through the cracks and the joints and the fissures in rocks, not in most cases not through the rock itself. We don't have any what they call primary porosity. So it moves through all these little cracks and fissures, which I imagine are little pipes going through. And depending on the type of rock, the pipes can be fewer, greater, smaller, wider, more interconnected, less interconnected. And that's where we can determine, is it a good aquifer if there's lots of pipes interconnected? Is it a poor aquifer? There's only a few pipes that aren't very well interconnected, or different layers perhaps. In a karst system, when the rainfall moves through, because it's ever so slightly acidic, and you're dealing with an alkaline-based rock, that it dissolves out the rock. So depending on the initial formation of the rock, whether it has lots of fractures and fissures naturally or whether it doesn't, it can dissolve that out and form preferential flow pathways. So it dissolves it out, forms these pathways and water likes the easiest route. So if it finds a nice pathway to run through, it'll keep running through it, dissolving it out. At the very extreme end, it would form caves like, for example, the Marble Arch Caves or the Galloway Caves, fantastic formations where you can go into. They're enormous caverns the size of rooms, and they have wonderful, geological formations such as stalactites and stalagmites and cave formations. And that would be the very extreme end of the scale. In most cases, we think that these fractures and fissures have been ever so slightly enlarged by the solution that's going through them. And what happens in those cases is that it can form intermediate spaces within the rock and it can be dissolved from the surface. So you actually get surface expressions of karst. Definitely you would have heard of things like collapse features or swallow holes, or there have been issues around the world where there have been collapses happening under houses and so on. So these sinkholes that forms, that type of thing. So they're all karst formations, and it's due to the rock's being dissolved out underneath. It can't support its roof, and then it might collapse completely, or it may dissolve out slowly and form little dish features on the surface. the interesting thing from our perspective in karst is that you tend to get very good water supplies in karst because they have a natural outlet, which would be a karst spring. And through the ages, people have seen this water coming out of the ground, used it. It's generally been okay. Because of these dissolved pathways through the rock and these connections to the surface through these features, it can be the case that perhaps contamination can get in more easily and move very quickly through karst systems. So as well as having good water volume, they can be susceptible to contamination depending on the land use.
And finally, just there's also some work in, I think you said one of the geohazard area with landslides in particular in Ireland.
Yes. So a number of years ago, there were a couple of large landslides that had quite an impact on local communities, such as the Derry Bryan incident there. And the Geological Survey of Ireland were called in because people didn't understand why this had happened. So from that we decided that we would start to catalogue these and look back historically to see what kind of a database we could build up, because it became more and more apparent that these, as you imagine, they're quite natural phenomena, and there are plenty have happened over the decades. So we started to look at those just to have the catalogues to inform people, and then to see were there any patterns occurring, and that then developed into seeing could you actually determine where they were more susceptible or not. So that's turned into a research project and also susceptibility mapping. So I think in the database there might be something well over 2,000 landslide events going back maybe hundreds of years, and we're looking at more and more ways of mapping those and understanding those. So we currently have a susceptibility mapping methodology, and there's a susceptibility map that's available online. I suppose in those areas where it is susceptible, it may be to do with perhaps where there's more peat, where there's rock issues, and of course rainfall, which isn't a factor I don't think we take into account currently. And in those areas, maybe the developments might be more around wind farms and that type of thing. So it's, in the development of those types of developments, what do you need to do to make sure that you don't instigate anything, and to be aware of the susceptibility of the local geology.
And that data is also available, of course, for the community to also make that same assessment.
So it's a policy of the Geological Survey to have free data. So all of the data that we collect, once we process it, it is available online, as well as going out to the individual stakeholders.
Now, I thought we would kind of focus in narrowly on a couple of projects. One which is a little bit outside your groundwater area, but not maybe some of it, is the TELUS project.
It has been running for maybe in the last sort of decade. That's been one of the bigger projects. It originally started in Northern Ireland, and what it is there's two main strands, whereas there's an airborne geophysical survey, and then there's also a ground geochemical survey. The airborne geophysical survey collects magnetic information, EM information, which is electromagnetic information, and then also gamma ray information. And it's basically images what's underground at different levels. So it's really interesting information. It was initially, the whole project was initially set up to inform the mining area, really, because especially with that information on the geology, and also the ground geochemical information, which I think they collected in around 50 or 55 parameters from soils and from streams and stream beds. Combining those two maybe can indicate the geology, what kind of mineralogy there might be, and whether there's any sort of economic minerals that could be
commercially exploited.
Exactly. So that, I think that was the basis, and that's been very effective in making that data available, has been very effective in getting mining companies interested in investing and looking at Ireland and seeing what else we can do. But there have been lots of other elements to that, sort of more on the environmental side. They can use that information, for example, for health, human health. So they're working with the Radiological Protection Unit within the EPA to refine the radon maps. Much more so, because previously it would have been done on measurements of becquerels within homes, which is very sporadic, and it's done, it's quite discreet. Whereas now we can pick up from the geochemistry, because it's so standardised, the mapping across different areas, and see different patterns. So I think that's really helped there. In terms of farming and animal health, they use some of the elements like cobalt, for example. They can get a really good image of what cobalt levels are across the land, and that I know that is useful for health in sheep.
Oh, I see.
Yeah,
Okay.
so the different minerals for different animals is useful to see where they're deficient, for example, and where they can be improved. And then, even in terms of perhaps, farming and working with Chuggusk to see they work at more refined level, the field scale level, but to see what the background levels are and see what they need to do in terms of farm scale management, so they can maximise their returns without contaminating the environment. So there's a lot of
now, Monica, the TELS project, when it did Northern, did it do just the border region, or did it entire Northern Ireland?
Yeah, so it started in Northern Ireland, and it's done the entire of Northern Ireland, and that was a Northern Irish venture. Certainly then we were in discussion with them about the TELUS border region. So that was a cross-border initiative which covered part of Northern Ireland and also then came into the Republic of Ireland. So that was EU funding Interreg project. So that was a wonderful cross-border initiative, to get that information. And that then has spurred us on then to doing the rest of the Republic of Ireland. That's Exchequer funding in the main, government funding, because they see the benefit of continuing that programme of work. The airborne geophysical programme is slightly ahead of the geochemical programme. The aim is to have half the country done by, I think, the end of 2017. And I think that the airborne geophysical survey will be completed or near completion by the end of this year, so that's ahead of schedule. The geochemistry is obviously it's quite labour intensive,
more time consuming.
Yes, so that has to they have to go into the field and actually take the samples, so there's a lot more involvement.
Have you used drones in any of these applications?
Yes, we're moving more and more into that. So we've actually, on the Infomar programme, a drone was purchased last year. And for their programme of works, they're mapping the seabed and bathymetry, and a lot of that information would go into, for example, working with the national parks, habitats and SACs and delineation of those. There's also, of course, looking at renewables offshore, wind farms offshore, that type of thing, and it feeds very much so into the navigation maps as well. So there's some primary uses for those. There's the intertidal zone, which of course the boats can't go into, and other mapping programs don't go out to. So they're looking into drone technology to capture that zone.
And that's an important zone for
it is
ecologically.
Very, absolutely, probably one of the critical ones ecologically and environmentally, and it feeds into the Water Framework Directive in estuaries and transition zones. So that they're testing that at the moment, and that's really good, because they're not only testing it for intertidal, but they're also testing it for things that we would like to do, like karst mapping, so karst feature mapping. Again, that would have been a field mapping programme, so we don't have a full comprehensive suite of karst features. We have very densely mapped karst features where we've had specific programmes like a source protection programme or a research study, but we don't have that across the country. So drone technology, we hope, will help that.
Actually, your work with the karst is a good segue to talk about one of the Groundwater 3D projects, which is part of your mapping program, and in particular, some work you did for a group water scheme in Roscommon. I wonder if you could tell the audience what that was.
Yeah, there's approximately 250 group water schemes that are supplied by Groundwater. So we have a program with the National Federation of Group Water Schemes to delineate catchment zones, bespoke catchment zones around their supplies, so they can then know where do they need to protect the land more so it doesn't contaminate their supply. But what's happened in an area, for example, in North Roscommon, where they have a lot of karst supplies for both public and group water schemes, is that they're coming up with the same issues. We're finding it hard to delineate the catchments because of the complexity of the geology and the hydrogeology. So we know from our mapping side, the 3D mapping side, that we need to do certain works. They need that for a specific reason, to protect their drinking water supplies. The two have come together, and now we're undertaking in that area, for example, we've worked with the group water schemes specifically. We've focused our mapping efforts there to have a very large tracer test study there. So over the last year or year and a half, we've been repeatedly putting in different dyes, and we've been monitoring all of the group water schemes, all of the springs, any outflow rivers. There are 7 or so group water schemes and public water supplies within the central northern Roscommon area, and we can work around all that entire area and delineate all of those catchments by doing this and working, looking at all of the outflows, all of the springs, all of the rivers. The team have just delineated some more robust catchment zones for the group water schemes after that work.
Now, when they identify it, does that then allow them to kind of protect those zones from from activities that would intrude in on the water supply, and buffer zones, for instance, or whatever?
Exactly,
Okay.
yes. So, if you have a spring, I suppose if you don't really understand about water movement, or you might be concerned that your well is in a certain location, you might be looking at the wellhead protection around that particular borehole or spring. Whereas in fact the water could come from 3, 4, 10 kilometres away.
Okay.
The catchment area could be very varied. So we delineate the catchment zone. If we've been doing this type of more intense study, we can actually identify where there are specific input points into the karst system, in this instance, that feeds that spring or borehole, and then the group water scheme, and with the help of the local authority, can go back and protect zones within that area, and also maybe even around certain inputs, certain swallow holes, they can say, okay, fence off this area, buffer this area.
Now, one of the other kind of applications that you've been working with is with the Turlogs and its impact on flood management, which is a very critical issue these days, and will get worse as climate change
Yes, potentially,
moves on.
yeah. They are seasonal lakes essentially, but they fill up with groundwater. Now, there's different methods that they can fill up. So in a lot of cases there's a hole in the bottom that's called an estival, which is a swallow hole and also allows groundwater in. So as the groundwater level rises in general throughout winter, these are surface expressions of the groundwater where they fill up. It forms a surface lake, and then they empty when the winter and the rainfall dissipates. And they form a certain type of ecology. So they have an ecological status. They're generally protected areas as well, and they're quite unique to Ireland. I think there's a few outside of Ireland, maybe in Slovenia and those very karst areas, 1 or 2 in Canada, but they're not, they're really quite unique to Ireland. More recently, yes, there have been issues with flooding more so, and flooding remaining or overtopping what was the traditional Turlock area. We know that there are different forms of them, how they function, and so really, if you're looking at managing them, it's not a one size fits all. You can't apply one management to all of the Turlocks, unfortunately. So with the flooding issue in the last winter, because it was it's record breaking rainfall over a longer duration than perhaps we saw in the 2009 floods. So it was a different form of meteorological conditions, and this has impacted worse so on the Turlock areas, because they flood due to the rainfall, but because the whole groundwater system is full because of the duration of the rainfall, they then cannot drain away as they normally would in the summer or in the springtime, and also because of their record-breaking rainfall, they have exceeded their natural boundaries, and over the course of the years, certain houses maybe have been built within those the flood areas that perhaps are just off the traditional boundary of the Turlock, or roads often skirt around Turlocks because people would have known that these were natural flood areas, put the road next to it, and now because they're flooding, or they did last winter, that has caused a lot of trouble for people, and difficulty, and of course it's very emotional if your house gets flooded for a long duration. So we've been lucky enough then to had funding now this year to go in and monitor the Turlocks and model the Turlocks within, for example, the Roscommon area, where there has been more issues this year or last winter, and that's a 3-year programme where we're going to be monitoring water levels. We're going to be looking at getting expertise with Turlocks, working with Trinity College. They're going to they're providing research into that as well. And the idea would be that we can model those, understand those better, and then inform the proper stakeholders who are managing this, so local authorities and the OPW, who are the competent authority looking after floods, to make them have workable solutions, really.
And also very important for planning purposes, that people are going to know that the Turlock is going to spread further, that's not where you build a house. Hopefully.
Yes, because there isn't really adequate flood hazard maps in those areas currently, and also for planning as well, yes, to make sure that we have the proper maps in place to inform the local authorities that we need to move planning away from these Turlocks.
Okay. Now, and as we talked about earlier, all the data that you generate is useful for local authorities as we've talked about, the planning authorities, and for some commercial companies, mining companies, gold minings, but is also available to the public and to environmental groups as well as anybody else.
Absolutely, yes. I mean, we have all of the data online as soon as it's available. There are obviously files, historic files in the Geological Survey, so we do get a lot of telephone inquiries asking is there more information, or people come in and look at historic maps, that type of thing. And anyone can access the data. We're a government division, so all of our data are freely available to everyone, unless there's confidentiality issues or with commercial sensitivities, that type of thing. But generally, we don't get hold of that information until those confidentiality issues have expired.
Great. Monica, thanks for talking with us today.
Thank you, Robert.
Okay.